The United States Air Force currently stands at a precarious intersection of history and innovation regarding its pilot training pipeline. For more than 6 decades, the Northrop T-38 Talon has served as the foundational platform for American fighter instruction. This airframe is so antiquated that the pilots training in it today are frequently the grandchildren of the first generation to operate the aircraft in the 1960s. While the T-38 was an aerodynamic marvel of its time, it lacks the avionics, angle of attack capability, and sensory feedback required to prepare aviators for fifth-generation fighters like the F-35 Lightning II and the F-22 Raptor. To bridge this widening technological chasm, the Pentagon initiated the T-X program, a competition that resulted in the selection of the T-7A Red Hawk. Although the prime contract was awarded to the American aerospace giant Boeing, the engineering soul and structural philosophy of the aircraft reside largely in Linköping, Sweden. For observers of the Swedish defense industry, the T-7A represents significantly more than a commercial export victory. It serves as a validation of Swedish industrial efficiency and digital engineering methodologies applied on a superpower scale. The genesis of this partnership was initially viewed with skepticism by defense analysts. The T-X competition pitted the Boeing Saab team against entrenched competitors offering proven, existing platforms. Lockheed Martin proposed the T-50A, a derivative of the South Korean T-50 Golden Eagle, while Italian firm Leonardo offered the T-100, based on the M346 Master. Both competitors argued that their off-the-shelf solutions offered lower risk and immediate availability. In contrast, Boeing and Saab proposed a clean sheet design, a strategy historically associated with high costs and lengthy development timelines. However, the team wagered that a purpose-built aircraft, designed specifically for the U.S. Air Force requirements rather than adapted from existing airframes, would offer superior long-term value. This gamble relied entirely on the ability to shatter the traditional cost curve of military aerospace development. The division of labor within this transatlantic partnership was calculated to leverage the specific strengths of each entity. Boeing provided the massive production capacity, supply chain management, and political capital necessary to navigate Washington. Saab, conversely, provided the agile manufacturing methodology and advanced aerodynamic expertise. This methodology is centered on model-based definition, or MBD. Unlike traditional aerospace engineering, which often relies on two-dimensional drawings, paper blueprints, or physical mock-ups, the T-7A was incubated entirely within a three-dimensional digital ecosystem. Every rivet, hydraulic line, and structural frame existed as a precise digital twin before a single piece of metal was cut. This approach allowed engineers in St. Vet, Louis, and Linköping to collaborate in real time on the same dataset, effectively erasing the Atlantic Ocean as a logistical barrier. The metrics yielded by this digital-first approach are statistically significant for the global defense sector. The program transitioned from initial computer concepts to the first flight in just 36 months, a time frame historically unprecedented for a modern high-performance jet. Engineering quality data indicates an 80% reduction in assembly time and a 50% reduction in software development errors compared to legacy fighter programs. These figures suggest that the efficiency measures perfected during the development of the JAS-39 Gripen E have been successfully transplanted into the larger American industrial organism. The most tangible evidence of this success lies in the aft fuselage, the complex rear section of the aircraft housing the engine and tail, which is designed and originally manufactured by Saab. From a propulsion standpoint, the selection of the General Electric F404 engine provides another layer of synergy for the Swedish partners. This engine family is well known to Swedish engineers, as a variant of it, the RM-12, powers the Gripen CD fleet. This commonality ensures that Saab engineers possess a deep institutional understanding of the thermal and vibrational characteristics of the power plant, further de-risking the structural design of the aft fuselage. It represents a pragmatic engineering choice that balances performance with reliability, a hallmark of Swedish defense procurement. A defining moment for the program, frequently cited by engineering leads to illustrate the efficacy of model-based definition, occurred during the initial assembly of the first test aircraft. When the Saab-built aft fuselage was shipped from Sweden to the Boeing facility in St. Louis to be mated with the American-built forward fuselage, the sections joined with near-perfect precision. The alignment was so exact that shimming, the standard aerospace practice of using material to fill small gaps between fuselage sections, was unnecessary. This level of manufacturing fidelity vindicated the decision to rely on a single, shared digital source of truth rather than traditional manufacturing tolerances. It demonstrated that Swedish precision manufacturing could stabilize the often unpredictable variables of a new aircraft program. However, an objective analysis requires acknowledging the friction points inherent in such complex multinational undertakings. Despite the initial speed of the prototyping phase, the T-7A program has encountered significant headwinds in the testing and validation stages. The production decision, known as Milestone C, has been delayed until 2026, pushing the initial operational capability, or IOC, to the 2027 to 2028 timeframe. Critical voices within the defense community note that while the airframe structure, Saab's primary responsibility, remains sound, integration issues have plagued the testing phase. Specifically, challenges related to the escape system and flight control software at high angles of attack have slowed progress. The escape system issues, involving the ACES-5 ejection seat manufactured by Collins Aerospace, highlight the risks of integrating new airframes with safety-critical subsystems. While these delays are technically the responsibility of the prime contractor and U.S. Air Force testing protocols, they inevitably impact the perceived momentum of the Swedish contribution. From a geopolitical and industrial perspective, the establishment of the Saab facility in West Lafayette, Indiana, marks a permanent shift in Swedish defense strategy. By shifting production of the aft fuselage from Linköping to Indiana, Saab has insulated itself against Buy American protectionism. This facility allows Swedish technology to be labeled as domestic U.S. production, securing long-term revenue streams from maintenance and future upgrades. This localization strategy also positions Saab to influence potential derivatives of the T-7A. Speculation exists regarding a light fighter variant, colloquially termed the F-7, which could replace aging F-5 and F-16 fleets in nations unable to afford the F-35. For nations requiring a capable but affordable platform for air policing and light attack, a weaponized T-7A could serve as an attractive alternative to the Gripen, or perhaps a complement to it, depending on the market segment. The strategic relevance of the T-7A extends beyond the bilateral U.S.-Sweden relationship. In November 2025, BAE Systems joined the Boeing Saab team to offer the T-7A for the United Kingdom's looming pilot training requirement. This move suggests that the T-7A could become the standard NATO trainer, creating a comprehensive ecosystem of interoperability across the Atlantic. If the Royal Air Force adopts the platform, it would cement the design's status as the definitive Western trainer of the mid-21st century. This potential standardization offers immense logistical benefits, as spare parts and maintenance procedures could be shared among NATO allies. Nevertheless, the path forward is not guaranteed. The program is currently operating under a fixed-price contract, meaning cost overruns largely eat into Boeing's profit margins rather than taxpayer funds. This financial pressure forces the consortium to resolve the remaining technical hurdles rapidly. The success of the T-7A is mandatory for the U.S. Air Force, which cannot extend the life of the T-38 indefinitely without compromising pilot safety and readiness. The pressure is equally high for Saab, as the program represents its most significant foothold in the American market. In conclusion, the T-7A Red Hawk is a case study in the leverage of niche high technology. Sweden, a nation with a population smaller than the state of Ohio, has provided the structural engineering foundation for the next generation of American air power. While the program faces the typical turbulence of modern defense acquisition, delays, integration bugs, and budget friction, the core achievement remains intact. The collaboration has proven that the digital engineering lineage of the Gripen can scale to meet the demands of a superpower. The T-7A serves as a hybrid machine, bearing American insignia and firepower, but retaining a distinctively Swedish industrial DNA in its bones. It stands as proof that in the modern defense landscape, the ability to design smartly is just as valuable as the ability to produce massively.